Let's start by creating a simple client as we always do for a three-tier architecture. We have a client which is web-based or it could be iOS. This client or user is creating the tweets or loading the timeline in the home page from the service. This service has exposed the endpoints, what we have discussed, for view feed and let me say view timeline here, which is specific to Twitter, post tweet, like or dislike tweet, comments on a specific tweet, follow and unfollow the users. These APIs, which we are exposing through a monolith service and exposing these endpoints. So far, we are talking about the relational DB. We are not making any choice as of now which DB we wanted to use. It could be like Postgres, it could be a SQL database. But the important thing is we have created the entities like user, tweet, like, comment, and the relationship. These entities in the database we wanted to expose through REST API, and this REST API will fetch this information from this single instance of the database. So now you can talk about how you wanted to perform the query here. This is a monolith service and it's okay to start with, but this is not a scalable system. When this user is loading a feed into their timeline by calling this view timeline API. View timeline API will query the database to know how many tweets that needs to be published into the home page. So if they are following thousands of users, so if we are performing a join query operation into a single instance of the database, will not be able to meet the SLA when we are getting thousands of requests per second while querying the join operation for the entire table. You would be able to understand that we are able to connect the dots here, the schemas or core entities what we have proposed and the API what we have mentioned. We are able to make the system satisfying all the core functionalities working end to end. But to make the system scalable for thousands and millions of daily active users, we need to talk about the scalable part of the system, which is our step number 6, deep dive of this system. So let me remove this and have the API gateway added here as we always do for deep dive. This it would be the first interface for our clients to interact, and this API gateway would be serving for load balancing or routing if we are talking about the multiple microservices, and rate limiting, authentication and authorization. And we are using the multiple instances of a single service, then we will doing the load balancing by this API gateway by a round robin fashion or by looking at the performance of the server, that the request needs to be forwarded to which server. Rate limiting is like in a specific time duration how many requests would be allowed, so that any malicious attack which is trying to make the system down, those requests can be ignored. Authentication and authorizations can be performed once the request is received by this API gateway, so that the same authentication and authorization need not to be performed from each of these microservices. So for our scalable system, let's start by thinking about how many microservices we need, and we should be able to justify if we really need to have this as a separate microservice. So this client is interacting with this API gateway, and the core functionality of the system is first to view the timeline. So it's a timeline service which would be able to fetch the timeline for a particular user, and we do not want to basically compute these timeline at real time. So it's something like we should have a pre-computed timeline available so that we will be able to serve the request as and when it is received into this service. So let's start thinking about that approach, that somehow these timeline or the list of all the tweets is available in memory. So we can use a Redis cache for this in memory, and this is a timeline cache here. Timeline cache, this Redis cache would be available. So we will not think much about, like, as of now. That's how we got the idea that we need a pre-computed cache. How do we need that? Let's park it aside. So when request received to load the timeline, and we can query this cache and fetch the list of the tweets. So this cache contains the list of tweet for a particular user. So that would be the key in the cache, user ID, and the value would be the list of tweet. Let me move this Redis keyword here to make some space. So yeah, this is a cache. Next is the tweet service. So tweet service, here user is able to post the tweet, and whenever there is a tweet is being posted, this service is going to save into the database for a particular user. So we would need the user service as well. And why we are not making as part of tweet? Because this tweet and users are independent, and we can perform this query independently, and probably we can make this information available into our cache. So we have a user service. This user is able to create the relationship, like if user A is following user B, from the user service this relationship would be stored in our DB. Let's call that as relational DB. Based on our initial table, we have a relational database here. So these are the important service, like and comment. Let's park it for the later part. So now here let's focus on the timeline, how we wanted to build this list of tweets for a particular user. So if you see, whenever there is a tweet is posted by a user, this tweet is being saved into the DB. We can also post this into some service which can do the computation. So this list of tweets would be pre-computed as soon as the tweet is posted by a particular user. This could be a message broker. We could make a choice of using a Kafka in this use case. So this Kafka, whenever there is a tweet posted, this tweet service can publish the message into the Kafka layer, as well as it can save into the DB database. So the kind of consistency what we are looking for this posting a tweet, right, that is the most important. So the guarantee what we can think about here, the service goes and save this into the database and provide the confirmation to the user that your tweet has been saved into our system, right? Asynchronously it can post the message to the Kafka as well, because this would be our asynchronous path, and this is where we have proposed the availability over consistency. So this is what it is, a synchronous path here for the write, and this path is asynchronous. So when the message is being published to this Kafka, there would be a consumer. There is a group of consumer here, or worker you can say. So let's say feed creation worker. This could be a batch job or a real time. So now here we are considering this as a kind of a consumer at real time. So whenever there is a message published in the Kafka, these consumers would pull this message from the Kafka topic, and these consumers will add these information into the Redis cache for the users, so that they don't have to do the any computation. So as you can see, as and whenever there is any tweet posted by user A, we are publishing this message into the Kafka. Tweet is being pre-computed and make it available for user B's timeline. So when user B loads the timeline for their home page, they will just read from this cache and have this information available in their timeline within a few milliseconds, and it does not have to query any database. So that is the benefit of pre-computation.